All right, so good day, everyone. I trust we are all doing fine. You are welcome to KSEC tutorials, and this is our very first YouTube tutorial video. You guys are welcome, and in today's video, we will be looking at empirical and molecular formula. We'll be looking at empirical and molecular formula. It's a very basic aspect of chemistry that you know it's important you understand well. If you're writing UTME, if you're writing WAEC, if you're writing GCSE, GC, NECO, um, NAPTEB, yeah. So it's a very important and basic aspect of chemistry. But then, the questions can be quite tricky sometimes if you don't know how to, if you have not tested yourself on different aspects, you guys can be asked questions from. So we'll be after the brief or basic terms I'm going to be defining and some steps I'll be giving. We'll be solving questions on, the various ways you can be asked questions on. So we'll be looking at it. So ensure you follow to the end. So let's move to the next slide. So yeah, I decide to actually write this down so that I don't get to waste time writing it down because I don't want the video to be too long. So yes, what is empirical formula? So yeah, I wrote it that empirical formula is the simplest chemical formula. The simplest chemical formula of a compound. It tells us majorly two things. The component element in the molecule of the compound. Component elements in the molecule of the compound. It should be elements in the molecule of the compound, and the simplest whole number ratio in which these elements combine in one molecule of the compound. I'm going to explain. So now, to molecular formula of a compound gives the exact number of moles of atoms of the component element in one mole of the compound. It is the actual chemical formula of a compound. So empirical formula is the simplest chemical formula. Molecular formula is the actual chemical formula of a compound. Take note, that's a major difference. You can be asked your objective, which of the following is true of empirical and molecular formula. So empirical formula is the simplest chemical formula. Um, Molecular formula is the actual chemical formula of a compound. Now, empirical formula and molecular formula are chemical formulas. So let's use chemical formulas to explain them. For example, let me write about five. Okay, I have CH3, 1 mole. This is methyl group. Let's write the alkane series. So we have CH4, C2H6. Yeah, that's ethane. We have C3H8. We have C4H10. So this four, we are using the alkane series plus this methyl group to just explain what empirical and molecular formula is. So now, looking at these four, which one of them can we term an empirical formula or a molecular formula? There are some of them here that we cannot say they are empirical formulas. So how do we know this? Remember, I said that empirical formula shows us the component element in the molecule of the compound. Molecular formula also shows us that. So you see that this compound contains carbon and what? Hydrogen. It's a combination of carbon and hydrogen. Molecular and empirical formula shows us that. But then the major difference is that empirical formula shows us the simplest whole number ratio in which this element combine in one molecule of the compound. It shows us the simplest whole number ratio. So now let's look at the ratio in which everything combine. And let's see the ones that are empirical formula and the ones that are not. Now, the ratio in which carbon and hydrogen combine here is 1:3, right? We have one, this is one molecule of methyl group. This is also one molecule of methane, one molecule, when we say one molecule of a compound. So let's say NaCl. This is one molecule of NaCl, 2 moles or 2 molecules of NaCl, 3 moles. So it's the coefficient, the stoichiometric coefficient in front of it. That's what we um that's how we know if it's 1 mole or 2 moles or 3 moles. So now this is one molecule of methyl group CH3 that contains 1 mole of carbon atoms or one carbon atom and 3 moles of hydrogen atoms or 3 hydrogen atoms. So the ratio in which they combine is 1:3, right? Here we have 1:4. Here we have 2:6. Here we have 3:8. And here we have 4:10. Right? Now, remember that empirical formula tells us the simplest whole number ratio in which the elements combine. Simplest whole number ratio. Simplest whole number ratio. Now, we can have a ratio that is not in the simplest form. For example, when we have, let me say 6:10, this is not in the simplest form. How do we know? Because there is a common number that can divide both of them, which is 2. So 3:5 is the simplest form of this ratio. I hope this is clear. So looking at this ratio in which, looking at the ratio in which these elements combine, we can say that this 1:3 is in its simplest form because there is no common number that can divide both of them that will give us another whole number. So this still becomes CH3. So this can be tagged as an empirical formula. What about CH4? There is no number that is common that we can divide that will give us another whole number for both of them. So CH4, it still remains CH4. So this can be tagged as an empirical formula. As an empirical formula. So what about C2H6? That's ethane. Now, if you see this, 2 can go in 2, 2 can go in 6. So there is a common number that can divide both of them that will give us another whole number. So we have 1:3. 2 in 2, 1. 2 in 6, 3. So the empirical formula of C2H6 is CH3. So this is not an empirical formula. This is not an empirical formula. What about C3H8? There's nothing that is common that can go in both of them that will give us another whole number. So this remains this, sorry. So this remains C3H8. So this can also be said, we can also tag it as an empirical formula. What about this C4H10? 2 can go in 4 and 10. So we have 2:5. We have 2:5. 2 in 2, 2 in 4 is 2, 2 in 10 is 5. So the empirical formula of this is C2H5. So this is not an empirical formula. We cannot tag it as an empirical formula. So you guys can see the difference between molecular and empirical formula. To see if something can be said to be an empirical formula, we have to check the ratio in which they combine. It has to be in the simplest ratio. So now I also need to say this, that sometimes the empirical formula of a compound can also be said to be its molecular formula, can also be its molecular formula. So for example, this CH4 is also the molecular formula of methane. Remember that Molecular formula of a compound gives the exact number of moles of atoms of the component element in one molecule. This is one molecule of methane. So anywhere in the world, one molecule of methane contains 1 mole of carbon atoms and 4 moles of hydrogen atoms, or 1 mole of, or 1 carbon atom combined with 4 moles of hydrogen atom. Everywhere in the world, 1 mole of methane contains this 1 mole of carbon atoms and 4 moles of hydrogen atoms. Also, this is propane. Even if you can call this an empirical formula, it is also the actual formula or the molecular formula of propane, because anywhere in the world, 1 mole 1 mole of propane contains 3 moles of carbon atom, or 3 carbon atoms. They are the same thing. And then 8 moles of hydrogen atoms, or 8 hydrogen atoms. So a compound empirical formula can also be its molecular formula. So let's move to the next slide. Steps to find empirical formula. Steps to find empirical formula. So the first step is to find the mole of each component element. Find the mole on each of each component element, and two formulas to find mole. We have two formulas I gave here. You can use the percentage by mass of element in the compound divided by the relative atomic mass of the element, or you can use reacting mass reacting mass of the element of compound divided by the relative atomic mass of the element. Depending on the parameter given, if it is the percentage by mass of element, so you use this. If it was the reacting mass, use this. For example, percentage by mass of elements comes in percentage form. For example, you can say, okay, a percentage by mass, a compound containing 60% percentage by mass of carbon. So you know that carbon is 60 and hydrogen 40, and it contains 40% percentage by mass of hydrogen. So from here, how do we find the mole? 60, we write it 60 divided by the relative atomic mass. You should know that in your head. The relative atomic mass of carbon is 12. Sometimes you may be given, sometimes you may not be given. So this is 1. So you divide this and then you get your answer. That's 5:40. That's 5 and 40. That's 5 and what? 40. So the next step is to divide the mole of each element by the smallest mole. So divide the mole by the smallest mole. The smallest mole here is what? 5. So you divide both sides by 5. So this is 1/8, right? Then attach, that's the second step. I've done this. The last step is to attach the number attach the number gotten as a subscript to the chemical symbol. So this, we attach it as a subscript. But if we have 1 here, we leave the symbol like that. We don't write anything. So this becomes CH8. You write the 8 as a subscript. So this is the empirical formula. So this is basically how to find empirical formula. Let's move to the next one. How to find, how to find molecular formula. Let's quickly look at this. How to find molecular formula. Now, to find the molecular formula of a compound, we need two major things. We need the empirical formula, which I've given you guys the steps, and then the relative molecular mass of the compound. Relative molecular mass of the compound. You need the empirical formula, relative molecular mass, and relative molecular mass, RMM, of the compound. I wrote it here that mathematically molecular formula is empirical formula times multiplied by this integer as a subscript n. So for example, when we have, okay, we have found n, I will explain how to get this n. For example, we find n to be 2, and we have probably C2H5 as the empirical formula. So what we do is that we multiply this C2H5 by 2, the subscript by 2. So we have C4H what? 10. So this becomes the molecular formula. That's how I wrote it here. That molecular formula equals empirical formula times this integer as a subscript. I hope this is clear. So now, how to find n? So we use the formula relative molecular mass of the empirical formula multiplied by n equals relative molecular mass or molar mass of the compound. So most times you'll be given the molar mass of the compound or relative molecular mass. Relative molecular mass and molar mass are basically the same thing, numerically the same. So if I have 100 as, I think 100 is the relative molecular mass of calcium trioxocarbonate 4, right? So this is also its molar mass. It's just that molar mass is expressed, is the unit of molar mass is gram per mole, while relative molecular mass does not have any units. That's just the difference, but they are numerically the same. So you can be given the relative molecular mass or the molar mass, it's the same. So yeah, we are going to first find n. We'll first need to look for the relative molecular mass of the empirical formula, and then we multiply it by n. So for example, let's say we have C2H5 as the empirical formula. How do we find relative molecular mass? Remember, relative molecular mass of the formula, you guys should know that. So that is the subscript 2 times the relative atomic mass 12. You add everything together. Once you multiply the subscripts times the relative molecular mass, you now add everything together. So 2 times 12 plus 5 subscripts times the relative atomic mass of hydrogen is 1. So n, let's say they give us the relative molecular mass of the compound to be, let me say, 240 example. So 2 times 12 is 24 plus 5, n equals 240. So we have 29n equals 240. So divide both sides by n. So the n you get, you now use it to multiply the empirical formula. So assuming, let me use for example, I got n as 2. The n is not 2 here, I'm just using as an example. So you just multiply it with this subscript. So 2 C4, 2 times 2 C4 and H10. Simple. I'm just trying to go back to the basics. So just trying to go back to the basics. So now I wrote it here that note that sometimes you may not be given the relative molecular mass or the molar mass directly. You have to apply other knowledge of chemistry to get it. This is where the question becomes very tricky for some of us. And sometimes you may not be given, sorry, sometimes you may not be given the relative, sometimes you may not be given the percentage by mass of element or the reacting mass. You have to look for it. This is why you need to solve as many questions as possible, so that when you are given questions on different angles, you can solve it. So let's move to the questions proper. So I think this is our first question. So yeah. Now this question says, sorry, let me clean this. This question says, find the empirical formula of a compound which, on analysis, yields the following as the reacting masses. Carbon, blah, blah, blah. Let me skip this. From your result, find the molecular formula of the compound if its relative molecular mass is 60. So, solution. This is a very simple question. Solution. Let's rule this so that it can be enough. Now, the first thing to write is the symbol of each element, CHO. Remember, the first step I said you should to find the empirical formula, we first need to look for the empirical formula. Find the empirical formula. So remember I said we first have to find the mole. Step one, find the mole. And mole, we have reacting masses. These are the reacting masses. Use the following as the reacting mass: 2, 0.34 and 2.67. And 2.67. Let me write my 2.67 well. So 2.67. Now, yeah, to get the mole, the reacting masses of the element divided by what? The relative atomic masses. These are the relative atomic masses given. Yeah. So we have 2 divided by 12, hydrogen is 1, and oxygen is 16. So 2 divided by 12 is what? Let me get my calculator. 2 divided by 12 is 0.17. 0.166 are to round it up. So this is 0.34, and this 2.67 divided by 16 is 0.17, right? So the next step, this is the mole of each element. So I said, if you remember, in the next step I said you divide by the smallest mole. The smallest mole here is obviously 0.717. So divide everything by 0.17 to get the whole number ratio. This gives us 1, this gives us 2, and this gives us what? 1. So you now attach these whole numbers as what? A subscript. So C, remember I said if you have 1, you leave the symbol, you write the symbol like that. CH2, H2, 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 H2O. So we don't need to put anything here. So this is the empirical formula. Empirical formula. So what about molecular formula? Let's quickly look for the molecular formula. So yeah, remember I said molecular formula, let me roll this, molecular formula equals empirical formula multiplied by n, this integer. So let me just clean this and write the empirical formula. This is CH2O multiplied by n. So how do we look for n? Remember I said relative molecular mass of the empirical formula multiplied by n equals relative molecular mass or molar mass. I'm writing in short form because of time, of the compound. Please, if you are writing WAEC, you have to write this. This is how you write it step by step. You don't just rush. If you are writing UTME, you don't have to do all of this. Just quickly do it, and in 10 seconds, 10 seconds, 20 seconds, you are done. But if you are writing WAEC, take your time to write it step by step, because you know, if you are asking your theory, your examiner will not mark your answer only. He or she will mark the step-by-step method you used. So you have to tell the examiner that you know what you are doing. So yeah, the relative molecular mass of the empirical formula will be what? Remember how I said you will look for it, the subscript times the relative atomic mass. So we have 1 times 2. You will now add everything. Once you addition of all this, the relative atomic masses of everything, but there are some, this now is going to be 2 times 1. This should be 1 times 12. This should be 1 times 16. So 1 times 12 plus 2 times the relative atomic mass of hydrogen is 1, plus oxygen 1 times 16, 1, 1. This 1, we don't need to write it, but we know 1 is here. So do bracket n equals what? 60. So this is 12 plus 2 plus 16, n equals 60. So this is 30n. equals what? 60. Divide both side by 30. So N is what? 2. Now, since we know that N is 2 here, the molecular formula is going to be CH2O multiplied by 2 as a subscript. This becomes C2H4O2. This is the molecular formula. This is looking like ethanoic acid. Yeah, I think so. Or we can write it as C3 CH3COH. This is ethanoic acid. So this is its molecular formula. Simple. Let's go to the next question because of time. Question 2. An organic compound contains 72% carbon, 12% hydrogen, and 16% oxygen by mass. The empirical formula of the compound is very, very simple. Very, very simple. Remember, the other one we were given, what were we given? We were given reacting masses. Here, we were given percentage by mass of each element. So remember the formulas I gave. You can use both of them depending on the parameters given to find your mole. So here we have the individual element as carbon, hydrogen, and oxygen. So we find the first step is to find the mole. We have 72 as the percentage by mass of carbon, 12 as percentage by mass of hydrogen, 16 as percentage by mass of oxygen. Here we were not given the relative atomic masses. Ensure you know many of it, at least the first 20 elements in your head. So as you continue to solve questions, calculation questions in chemistry, you know them. So the relative atomic mass of carbon is 12, of hydrogen is 1, of oxygen is 16. So we have 72 divided by 12 is 6. This is 12. 16 divided by 16 is 1. So now we now write it as a subscript. The empirical formula will be C6 H what 12 H12 and what H12, and this is O, because if you have 1 as the whole number ratio you are getting, as the whole number you are getting, don't put anything. So that's empirical formula is C6 H12. So this is the answer D. I just use the different parameters you can be given, so you use it to look for your mole. Remember the first one we were given was the reacting mass, and then this one the percentage by mass of each element. So depending on the one given, you can still use that to look for your mole. So the next question, the questions will be becoming tricky as we move on. So this question says 0.07 gram of a hydride of carbon occupies 56 centimeter cube at STP, standard temperature and pressure, when vaporized. Definitely this is a gas, and contains 14.29% by mass of hydrogen. The formula of the hydrocarbon is, so let's solve this. Solution. Formula of the hydrocarbon, that is the chemical formula, the actual formula. They're asking for the actual formula. They're asking for the molecular formula. So let's solve. Very simple question. So sorry, already written solution. So hydride of carbon, that's CH, hydrocarbon. So the individual element is CH. So to find molecular formula, you know you have to look for the empirical formula. So let's look for the empirical formula first. So CH, then we have mole, percentage by mass of 14.29. Okay, 14.29. We're giving percentage by mass of hydrogen to be 14.29, but we're not giving that of carbon. How do we get it? It's very simple. Take note that the addition of all the percentage by mass of each element should be equals to 100. So for example, let me write it. Percentage by mass, here we have carbon and hydrogen. Percentage by mass of carbon, by mass of carbon, plus percentage by mass of hydrogen, it should be equal to 100%. The addition of all the percentage by mass of each element in a compound should be equal to 100%. So remember, we're giving, let's just use this as X. We're giving percentage by mass of hydrogen to be 14.29. So what you just do is just subtract. You don't need to go through all this process. Just subtract it so that you get the percentage by mass of the element that you were not giving the value. So just add everything that you have for the values of the other elements you were given, and then subtract it from 100. You get the percentage by mass of this of the remaining elements that you're not given. So here we just have x, bring this here, it becomes 100 minus 14.29. This should give you 85.71. Yeah, am I correct? 7100. Yeah, it's 5.71. So this percentage by mass of carbon is 85.71. I hope this is clear. So in case you're not giving, don't panic. Just subtract it from 100. If there are three elements and you're giving the percentage by mass of two of the elements, add the percentage by mass of the two that you were given and then subtract it from 100 to get the third element. Simple. So here, after this, we divide it to get the mole. We divide it by what? The relative atomic masses. So divide by 12, divide by 1. 85.71 divided by 12. That this gives us 7.1425. This gives us 14.29. Divide both sides by the smallest mole. 7.1425 is the smallest mole. This gives us 1. This gives us 2. Obviously, this gives us 2. So the empirical formula is what? CH2. Empirical formula is CH2. Now, what is its molecular formula? Molecular formula. So remember, to find molecular formula, remember, is this empirical formula CH2 times N. Now, to find the N, now we say relative molecular mass of the empirical formula times N equals relative molecular mass or molar mass of the compound, right? Yes. But yeah, we know CH2, we can easily find the relative molecular mass of the empirical formula. But here we're not given the relative molecular mass or molar mass of the compound. How do we find it? From this knowledge here, from what we're given here, we can easily find it. But you have to apply another knowledge of chemistry. If you remember Avogadro's law on molar volume of gases. So he said that the molar mass of any compound, of any gas occupies 22.4 dm cube at STP, at standard temperature and pressure. The molar mass of any gas occupies 22.4 dm cube. Molar mass of any gas occupies oh, so the molar mass of any gas occupies 22.4 dm cube. All right. Now, this is a gas because I said it occupies a volume at STP. So this definitely is a gas. Yeah. So now, since we know that molar mass of any gas equals 22.4 dm cube, we can say 0.07 gram of the gas occupies 56.0 cm cube. So we cross multiply to get the molar mass. I hope this is clear. It's like when you have 1 dozen equals what? 12. And then I ask you how many dozen gives you 24. I hope this is clear. How many dozen gives you 24? So from here you can just cross multiply, or if you have knowledge, 2 dozen gives you 24. How many dozen will be 12? How many dozen will be 12? X dozen will be 12. So from here you can just cross multiply to look for it. So that's what we did here. So yeah, now we cross multiply, but we can't cross multiply directly. Why? Because these units, they have to be the same, though they are both units for volume, but then this, both of them has to be either dm cube or cm cube. I hope this is clear. So let's convert 56 to dm cube. So 56 cm cube equals 56 times 0.01 dm cube. So if you want to convert cm cube to dm cube, just multiply by 0.01. So this becomes 0.056 dm cube. So from here, we know that molar mass occupies 22.4 dm cube. This is mass and mass, 0.07 gram. Occupies what? 0.056 dm cube. So cross multiply. So we have 0.05 times molar mass. So let's just put 0.05 molar mass equals 22.4. Because of time, let me just calculate it directly. Times 0.07 times 0. When you cross multiply, you multiply this and you multiply this. You multiply this with this, multiply this with this. So this gives you 1.568. Divide both side by 0.05. 1.568 divided by 0.05. 0.056, sorry. So this gives us 28. Molar mass equals 28. Molar mass equals 28. So the molar mass equals 28. So we have found molar mass to be what? 28. So molar mass is 28. We know molar mass is 28. The relative molecular mass 28. So now, since we know the molar mass now, we can now find the relative molecular mass of the empirical formula, and then we can use it to find n. So relative molecular mass of the empirical formula, remember the subscripts times the relative atomic masses, then you add all of them together. So 1 times 12 plus hydrogen is 2, the subscript here is 2 times the relative atomic mass 1, open bracket, n equals 28. Remember molar mass that we found then. So this is 12 plus 2 n equals 28. So 20, this is 14 n equals 28. Bible side by 14. So n equals what? 2. So remember, we have the molecular formula to be this here, this here. So CH2 2 equals C2H4. 1 times 2 is 2, 2 times 2 is 4. So this is the molecular formula, C2H4. Very simple. Let's go to the next question, course of time. So question 4. Question 4 says an organic compound with a vapor density 56.5 has the following percentage composition. Let's quickly write our solution. Okay, these are the percentage composition of each element. So we are asked to look for the molecular formula of the compound. So how do we find the molecular formula? Very simple. So first find the empirical formula. Write the element, the chemical symbol of the element out. CHON. I'm writing it according to this option. CHON. Then we find the mole. The percentage by mass of carbon is 53.1. Hydrogen is 6.2. Oxygen is 28.3. Nitrogen is what? 12.4. So let me write my nitrogen well. Nitrogen 12.4, right? Now you divide it by the relative atomic masses. You guys should know this by now. divided by 1, divided by 16, divided by 14. So let's divide 53.1 divided by 12. This gives us 4.425. This gives us 6.2. 28.3 divided by 16 gives us 1.77. I rounded it up to two decimal places. So 12.4 divided by 14 gives us, let me just put that 0.089 or 0.08. Let's just use 0.089. So the smallest, you divide it by the smallest, which is 0.089, 0.089, 0.89, not 0.089. So 4.425 divided by 0.89 or 88, okay, divided by 0.89 gives us 4.97. I think let's change this to 0.885. It's too much. 885. 885. I think I'll recommend three decimal places at least. This becomes 885, 885, 885. So 885, um hold on, I'm coming. Okay, 12.4 divided by 14. 0.886, not 5. 886, please. 886. I rounded it up. It's 886, sorry. Let me clean it. 886. 0.886, 0.886, 0.886, 0.886. Yep. So this gives us 3.99. 4.425 divided by 0.886. That's 4.99. 4.99. That's 5. 6.2 divided by 0.886. That's 7. 6.99. So that's 7. 1.77 divided by 0.886. This gives us 1.99, which is 2. And this gives us what? 1. So empirical formula, you attach it as a subscript to the chemical symbol. That's C5. We have H7. We have O2. We have, is it O2? Yes. And we have N. 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 So this is the empirical formula. But remember, we have to look for the molecular formula. So how do we find the molecular formula? Molecular formula. So molecular formula equals, open bracket, C5H7O2 N times the integer n. And to find the integer, we need the relative molecular masses, and the relative molecular mass of the empirical formula, remember, times n equals the molar mass or the relative atomic mass of the compound. But we're not giving the molar mass again, we're giving vapor density. But from the knowledge of gas laws, if you remember, molar molar mass of a gas is 2 times its vapor density. So the molar mass of this will be 2 times 56.5. 56.5 times 2, that's 113. So we already know that the molar mass is 113. So molar mass is 113. So relative molecular mass, let's find it. We have 5 times 12. Relative molecular mass of the empirical formula plus 7 times 1, that's hydrogen. For oxygen, we have 2 times 16 plus 1 times 14 for nitrogen times open bracket multiply by n equals 113. So this is 60 plus 7 plus 32 plus 14, all multiplied by n equals 113. So 60 plus 7 is 67. 67 plus 32 should be 99. 99 plus 14 That is 113 times n, that's 113n. Bible side by 113. So n is what? 1. Very simple. N is 1. So the molecular formula will now be C5H7O2n multiplied by 1. So this gives us C5H7O2n 1 times 5. 1 times 7 is still that, is still 7. So this is the answer. The answer is D. D is the correct answer. So the only tricky thing here is the vapor density that we used to look for the molar mass. So let's go to the last question before I give the assignment. Now, this question says a sample of a substance containing only carbon and hydrogen bonds in excess oxygen gas O2 to yield 4.4 grams of carbon dioxide and 2.7 grams of water. The empirical formula of a substance. Here, they never ask us for a molecular formula, empirical formula. Let's write solution. We ask the empirical formula. So we know that the substance contains carbon and hydrogen. So we have to look for the mole. But now, we are not given the reacting mass. We are not given the percentage by mass of the elements. We are not given the reacting mass of the element. How do we find it? From this knowledge, from this, what we're given, we can look for it. Remember, they said the total yield, the total amount of carbon dioxide was 4.4. So we have 4.4 grams of CO2, right? And then we have 2.7 grams of H2O. So from here, we can find the reacting mass. We can find the mass of carbon in CO2. We can find the mass of carbon in CO2. Now, if you remember how um you find percentage by mass of an element. Remember, let's say you want to find percentage by mass of carbon in CO2 now. We say the relative atomic mass of carbon mass. Let me just write it in short form because of time. We say relative atomic mass of carbon over the molar mass of carbon dioxide times 100. This is how you find relative atomic mass times 100. This is how you find percentage by mass. Remember, so it's by percentage by mass of an element in a compound. So percentage by mass of this carbon here in CO2 is the relative atomic mass of carbon divided by molar mass of carbon dioxide of the compound times 100. But here we are looking for the mass of carbon in CO2. The mass of carbon contained in CO2. So we can also use this particular method, but we don't put 100%. We put the mass, the total mass that we are looking for, 4.4. So this is going to be relative atomic mass of carbon is 12 divided by the molar mass of carbon 2 oxide is, or relative atomic mass. Molar mass is also relative molecular mass. So how do you find it? 12, 1 times 12. We have 1 times 12 plus 2 times 16. 12 plus 32. That's 44. So the molar mass or the relative molecular mass is 44. This is in gram per mole though, but I'm ignoring the this thing, the unit. So 12 divided by 4, then 12 divided by 44 times what? 4.4. This will give us the mass. Anything we get here will give us the mass
of carbon in carbon 4 oxide. So this 12 divided by 4 divided by 44 times 4.4, that's 1.2 grams. So 1.2 grams is the mass of carbon. This is the mass of carbon in CO2. 1.2 gram is the mass of carbon in CO2. So we can also call this the reacting mass, because if you remember the law of conservation of mass, the mass that is used for reactants will also be the mass that we get as products. Like, it is not lost, no mass is lost. That's what the law of conservation of mass says. If you guys remember in the law of chemical combination. So we can also tag this as what? The reacting mass, 1.2. So we do the same also for what? Hydrogen. We can do the same for oxygen for both, but here we are dealing with hydrogen, and we are dealing with carbon and what? And hydrogen. So for H2, remember we have 2.7 grams of H2O. Now to find the amount of H2 in water, the amount of H2 in the total grams of water is still the same thing: relative atomic mass of hydrogen divided by this hydrogen gas divided by the molar mass or relative molecular mass of H2O as water times 2.7. This is okay. For example, they ask us to look for the percentage by mass of hydrogen in water. This is exactly what we'll do. I hope this is clear. This is exactly what we'll do. But here we are looking for the mass of hydrogen in water, the mass of hydrogen itself in this water. So this is hydrogen gas. So relative atomic mass of this, or I can tag this as the relative molecular mass of H2, because this is no longer an element, it's a compound, is a molecule. Sorry. So relative molecular mass for molecules, relative atomic mass for atoms, that's single elements. So here we have 2 times 1, the relative, this will be 2, H2, that's 2 times the relative atomic mass is 2, 2 times the relative atomic mass, this is 1, that's 2. So 2 divided by the molar mass of H2O is also the relative molecular mass. How do you find it? So 2 times the relative atomic mass of hydrogen plus 1, this is 1, you don't need to put anything here, so but you know there's 1 here, 1 times the relative atomic mass of oxygen, which is 16, that's 2 plus 16, which gives us what? 18. So 18 times what? 2.7 gives us the mass of hydrogen, H2, in H2O. So 2 divided by 18 times 2.7, this gives us 0.3 grams. So 0.3 grams can also be tagged or said to be is reacting mass. Remember what I said, that mass of a mass is not lost. Law of conservation of in a chemical reaction. So law of conservation of mass. So now what do we do next? We divide both sides by its relative atomic masses. Here we have 12 and we have what? 1, right? So this gives us 0.1, this gives us 0.3. Divide both sides by the smallest mole, 0.3. This gives us 1, this gives us 2. The smallest mole is 0.1, not 0.3. So this is CH2. The empirical formula is what? CH2. Remember, this was what we are asked to look for. Empirical formula is CH2. So CH2 is its empirical formula. So this is the answer. So with this, we have come to the end of this video. I hope you enjoyed this video. If you want to connect with us on WhatsApp, KSEC tutorials, Kingdom Scholars Educational Consult tutorials,
connect with us via WhatsApp 09070141587. Please, if you enjoyed these videos, like, subscribe, share so that you can receive notifications when we post new videos. So let me give you guys assignment so you put in the comment section. So this is an assignment for you guys. Just drop your answers in the comment section. If you have gone through the video well, you'll be able to answer this correctly. So drop your answers in the comment section. Thank you so much and see you in the next video.